So our next talk is around breakthrough moments in enterprise taxonomy management with our great friend Dave Clarke, the founder of Synaptica, and he is a long-term supporter of KM World, and we're very happy to have him here, and I'm in Bill's way, sorry. He served on the authoring committee of the 2005 version of the U.S. National Standard for Control Vocabularies. He leads research and development at Synaptica, including software solutions for taxonomy and ontology management, text analytics, autocategorization, image automation, indexing, and linked data management. I'm sure AI won't be coming your way, Dave. We know this. Anyway, please welcome Dave Clarke from Synaptica.
Lavia or? Oh, there you go. Okay, thank you. All right, so Synaptica has collaborated with our clients. This is what we do. Clients come to us with problems and we share our software, but we always are working to come up with new solutions with our clients. And we have a very diverse set of clients. We've been in this business for over 25 years. So in that journey, we've faced many challenges and we've had some breakthrough moments. And I'm going to talk about some of those today under some themes of complexity, scale, explainability, and trust. These are my dogs, Maximus and Huxley, happily having a picnic on the coast near where I live in Pembrokeshire. And they've got some wisdom to share as well. This is how Huxley and Max are composed. They are Heinz 57 dogs. They have a lot of diversity in their genes. And I want to just talk about tech stack diversity. And I think this resonates with some of the other talks, including Dion's, is there's a lot of stuff out there. And kind of our philosophy and the philosophy of some of our tech partners is stay flexible, don't tie yourself to one particular technology. In the LLMs, there are a lot of LLMs out there. Use diverse ones. There's a lot of NLP tools out there, and we're not tied to one. So we have taxonomy software, we have categorization software, which is built with our partner Ontotext, and the belief here is you need diversity in all of these components and tools. They're changing. There are different ones that are better at other different things, and keep your options open. Okay, on to the first challenge, which is complexity. So the complexity challenge is, oh, by the way, the artwork, any of the artwork here was generative AI generated with some prompts, library index, knowledge graphs, nice work. I'm not going to be spending as much money with Adobe Stock Art anymore, unfortunately. Okay, so complexity in our world is really about knowledge modeling complexity. And we have had several stair-step changes over the last few years, and I'm going to just briefly describe those. These are pretty much very familiar to everyone. Okay, so we made a change from terminology-based taxonomies to concept-based taxonomies a long time ago. Just a tremendous amount of value in that, but I will pick one thing, which is the job of building multilingual taxonomies suddenly became immediately easier because you could share a whole taxonomic structure just by adding language labels instead of having to build out these monolithic language vocabularies and intermap them. That's just one benefit from that change. We made the change, still making the change, but we've made a change from taxonomy to ontology. And Dean talked quite a bit about this yesterday, which was very informative. Essentially, I'll take the difference is the schema, the data model, if you like, of the taxonomy is itself semantically expressed, it's extensible, and therefore it supports machine interrogation, machine inferencing, and that was a really, really big leap to move from taxonomy to ontology. There was another complexity breakthrough when labels became things, and this is SCOS Excel, one of the industry standards or recommendations that kind of play here. Stephen King published The Shining under his own name. He published, I think, The Running Man under the name Robert Bachman. Normally in a taxonomy, these are an alt label to a pref label, and only the pref label is a thing. But in SCOS Excel, what if we want to say, I want to distinguish where Robert Bachman, what books he published, then the string becomes a thing, and you can do that. It all adds to the complexity of taxonomies. Then we had relationships as things. This is RDF star, which took RDF graph world closer to the property graph world, a big change, but you could say the connection between two things has properties. And then we get to knowledge graphs. And knowledge graphs is a really big change, and one of the key differences I would say here is the graph isn't just storing the ontological model, the graph is storing information about the content that the ontology describes. We call this content-aware knowledge graphs, but essentially when you bring that knowledge about content that an ontology is describing back into the graph, you can do amazing queries. Sarah Downs, my colleague, did a session or a webinar earlier where she brought in classified job listings and resumes. With the content-aware knowledge graph, you could then say, hey, here's the resume for John Doe. Find me the best fit job listings for this guy. And that's only when the graph is aware of the ontology and the content. All this complexity needs another big challenge solving, which is the challenge of the user interface and experience. We need to make the complex comprehensible and make it simple. Our application Graphite is what we call a simplification layer on top of all of this complex data models. This project was created by Aaron Leonard, a colleague of mine. It's called the Bondtology, and it's everything about Bond. It's a fun, extremely complex data model, gadgets and theme songs and actors and plots and everything, all mapped out. Just a fun way of illustrating how complex this stuff can get. Okay, challenge of scale. There's a very faint line underneath that arrow, and it is the thickness of 10,000 concepts. And many organizations don't go beyond 10,000 concepts in their taxonomy. Second line is 100,000 concepts in scale. And we work with many companies that have this is a large-scale taxonomy at 100,000. This is one that we started working with at the beginning of this year. It was a healthcare and medical business that had a taxonomy or taxonomies summing about 10 million primary concepts plus hundreds of thousands of properties. And they wanted sub-second response. There were challenges to getting that response, and there was also incredible challenges in the user experience, because imagine you're clicking through a hierarchy, and this is real stuff here. Click, click, click. The next one has 33,000 narrower concepts. So what we've done is we've created something called adaptive navigation. It traps it before it happens, it stops the problem, and it says, I'm going to give you a search box, and that search box is programmed to search inside the set of narrower things. Now we can go instantly from this to a sub-second query. In my example, I think I'm doing phototropic unclassified bacteria, sub-second response. This is how to navigate when you're at extreme scale. Similar example in associative navigation. We here have something where click, click, this is real data. There are over a million associatively related things. That then is trapped. It gives you a search interface. And here I was able to go and get 95 things out of the million within about a second. Also, scale is not just the amount of data, it's the complexity of the data model. So typically, enterprise taxonomies have about 12 predicates, maybe SCOS predicates. Maybe you add some custom ones and you get to 24. This particular use case we were dealing with had 662 relational properties. put those into a screen, it kind of breaks, but adaptively we made it not break by sensing how much was going on, showing the relevant properties, and making that all manageable. I'll skip through this, but these are the actual benchmarks of our tests over 7.1 million concepts in a taxonomy. When you have something specific that returns specific results, it's sub-second. If it's returning thousands of results, it will take a little longer, only a few seconds, but that is because it's retaining a lot of data. Okay, explainability. There are three pillars of a successful autocategorization that we try in our design to adhere to. Explainable results, transparent rules, and rapid iteration. So the explainable results is when you are, particularly when you're curating the taxonomy process, the tagging process, you can see what the results are, you can interact with that, you can click on it, you can see where it got to the decision it made. And from that, we get to transparency of the rules. This isn't a black box tagger. This is a tagger that the taxonomist has complete control over. They can go back. Let me just sort of skip through this. So this is SCOS, doesn't really support those explainability or transparency rules. So we created extensions to that, which are transparent. Basically, the ontology becomes the mechanism of transparency for the rules. So we have rules, we have predicates to say things like, it must not match this or it must match that. The taxonomist can see it, they can interact, and so you get this iterative, rapid iteration, which is really important. You can refine the rules, you can refine the tagging, and you can do it literally in 1 minute cycles to get the quality better. Generative AI. So I put this under the challenge of trust because, Dion, you pointed out a lot of important concerns here we have. And there's privacy, there's how does enterprise data stay sort of secure, there's opaqueness of sources, and there's the veracity of results. So, cited sources. I want to call out Squirro, who are here today. They're in the showcase, and a respected partner of ours. They created something. I was talking with our CEO at the beginning of the year, and he was like, yeah, I'm going to be all over this. He was all over this. In 6 months, they built Squirro GPT. It has enterprise-grade security. It's evidence-based. So he then, we put all of our user guides and public-facing documents into this, and you can ask questions. This question is, when do I use SCOS versus OWL? The answer that came back was actually pretty sensible. I could probably elaborate on it, but it's pretty sensible. The important thing is this red ring here, cited sources. It tells you which documents it was looking at to make that decision. It's not this big, vast void of general knowledge. Dean Alamang did a fantastic keynote at bootcamp yesterday. I used Bing Image Creator and said, come up with some images for Dean Alamang explaining LLMs. So from these unusual suspects, only one of them is real and 3 of them are completely made up. This exposes a common problem that we know with AI. It can come up with convincing, I'm not sure, Dean, who you would like to have as your avatar, but it comes up with convincing things that are entirely made up. So from Dean's talk, which was only yesterday, I picked up on a lot of things, but I wanted to pick up on 3 specific things and say today, and talk about them today. So Dean said, who understands why we need, who best understands, I would say, why we need taxonomy? And ChatGPT does, was Dean's answer. Dean had a case study that I believe he's going to make public in a few days, which had some metrical tests of doing work with LLMs only, and then combining the LLM with an ontology, and the improvement in accuracy, I believe, this is from memory, was 37% or over 37% in a specific test case. The important thing here is that you need taxonomy, you need ontology, you need organized knowledge organization systems in order to work with all of this wonderful, cool AI and large language models. They're not enough on their own. So we work, I mentioned, with OntoText for our tagging solutions. So we have Graphite, which is ontology management, taxonomy management, and we work with OntoText. OntoText have also been very busy this year, and they have introduced into their components through our components are called Graphite Knowledge Studio. This is how you can do taxonomy, tagging, ontology. And in Graphite Studio today, as a result of all the hard work that OntoText have been doing with LLMs, you can plug in a LLM service. You can use that service to help improve the quality of information extraction or tagging. There are other capabilities where you can talk to the graph. Basically, you can go and query the graph that you create through natural language, through GraphDB's plugin. So this is fantastic, fantastic developments. My only real closing comment here is keep your tech stack diverse and free up your imagination. Be bold. Dion, you said humans can start to perform like superhumans. They can, and Dean, yesterday you gave us the most inspiring rally call for embracing taxonomy and LLMs, and I thank you. Bye-bye.